Okay, welcome. We want to talk about something called state machines today. A state machine is a method of programming that allows us to do sequential tasks. So I could have some number of tasks here that I'm going through in sequence for whatever reason, controlling the machine, whatever it might happen to be. But the issue you have with sequential tasks is you have to go from one to the other to the other. What a state machine allows you to do is to jump out of that path and either go back forward or go backwards, or even move forward to some other state so that you can execute functions. So let's just say, for instance, we have a system where we're filling a tank. So the first thing we want to do, if we're going to be filling a tank here, is we're going to have to open. So we'll go here, and this is going to be our, if I can write, we're going to open our valve to start filling up. And then what we're going to do is we're going to go and we're going to check to see whether the tank is full yet. If it's not full, we're just going to come back and check again. And when it is full, then we're going to go on to the next step, which is to turn off the valve. Once we've turned off the valve, then we can do whatever process it is. And let's just say, for instance, our process demands that the tank be maintained at a certain fill level, but in the process of doing the mixing or whatever, that level may drop, okay? So now what we want to do is we want to watch our level, okay? And if our level is okay, we're just going to come back and check it again and do whatever it is we're doing. If our level happens to be too low, what we're going to do is jump back again to here, okay? Oops, sorry. We're going to jump back again. That didn't work. All the way back to here, open that valve again, and then check to make sure whether it's full or not, and then continue to do this process until whatever other test we're doing says I'm done. Okay? So if you were doing this in LabView, so I got to go back to here. If we were doing this in LabView, what you might want to do is normally say, oh, I got a sequence. Well, I'm going to do a flat sequence here, okay? The problem with the flat sequence is I can't jump out and go back again, okay? So we're going to use something called a state machine, okay? And the state machine basically is where each time you go to one of these things here, okay, that is a different state. It is a different event that is happening. So for instance, my events might be that I have things like open valve. My next event is going to be check the level. The next thing is close valve. Next thing would be to start my process, whatever that happens to be. The next thing is to check the level, okay? And then check process done. If process is done, then what I'm going to do is to go to whatever the finished process is, okay? And the result here is that when I'm checking level, if I'm wrong, I may need to jump all the way back to here, okay? So doing this, each one of these becomes a different state in the state machine, okay? So when we're developing a state machine, what we want to do is we want to have a case. So we're going to have a case here, okay? And we need this to be a numeric case. So I'm going to drop down a numeric control here, and I'm going to turn him into an integer. And then we're going to wire him to this, okay? So here's my first state right here. And let me just turn on the diagram labels here so we can see what we're doing. So the one we just looked at, my first state is to open the valve, okay? The next state is going to be to check the level, okay? The next state after that, oops, we got to add another state after that, okay? So then the next thing, once the level is there, we're going to close the valve. And then the next thing after that is add case after. We're going to start the process, okay? And then in step 4, we're going to check level and process, okay? So you can see what I'm basically doing is just creating what we just did a minute ago. Finish process. All right, so now we're going to go back to 0, which is where we're going to start. So what we're going to do in here is we're going to do some kind of code that says open the valve, okay? Makes no difference what it is at this point. We're going to open the valve, okay? Whatever, that might be something like a digital output or something like that. And then what we've got to do is we have to go to the next state. The next state would be 1. So what we're going to do right here is we're going to create an indicator, create a local variable right here. And we're going to go tell this that we want to go to state 1, okay? Now, the first thing you're going to say is, hey, wait a minute, I can't ever get to state 1 because as soon as this case is done, the program ends. And you are absolutely correct. So what we do is we control this by putting it into a while loop right here. And I'm going to make this executable by creating a control for it. There we go. I have a stop button up here, okay? So now what happens is this guy comes in, he says, I'm at 0, I'm going to do this. I'm going to set my numeric to 1, so this guy is now going to be 1. I get done, I go here, I loop back again, and I come in and say, oh, now I'm at numeric 1. So now I'm going to go here. So now I have to do something to check level, okay? So I'm going to just say, is my level greater than or equal to some preset amount? And I'm presuming here that this input is some kind of an analog input or something like that. So we might have, for instance, some kind of an analog read and say, hey, we're looking for this value to be this. So we're going to say, if it is, okay, if this is true, it is greater than, then we want to turn off the valve. So we're going to go to the next step. The next step would be case 2, okay? If it's not there yet, then we want to do this again. So now we're going to say, I'm going to be case 1, okay? And again, we're going to write this way and say, there it is. Now, this can be done without using local variables like this. It can be done with shift registers. I just personally prefer this method because it's a little cleaner to work with. So now it's going to say, if it's 1, I'm just going to keep looping on this guy. I'm going to loop on it, loop on it, loop on it until my output here exceeds 33, okay? And when I get to 33 or greater, then I'm going to jump to 2. And now this is where I'm going to, for instance, output my digital out here. Okay, so digital, there we go. So I'm going to do a digital out right here and tell, oh, I'm going to go write this. Okay, got to have a false. Now, obviously, I haven't done all the setup for any of this stuff to work, but that's fine. And then when I'm done closing the valve, where do I go? I have to go to step 3. Okay, so I'm going to go there, and I'm going to go to step 3. Step 3 starts my process, whatever that happens to be. Okay, and I'm going to just make a copy of this for the moment because I need another one right here. Okay, so this is start process, whatever that might happen to be. Then I'm going to jump to 4. Okay, and again, let me just make a copy of this guy because I need him again in the next one. So in this one, I have to check the level and I have to check the process. Okay, so if level is low, I need to go to 1. If the level is okay, I can check process. If process done, go to 5. If process not done, go to 4, which is where we are right now. So now we're going to have some multiple level of checks. And there's a couple of ways to do this. One is you can put a case statement in here. Okay, so here's my case statement. My case statement says, let me turn on the things here so that this is level okay. This is level low. So if my level is low, what I want to do is to go back to case 1, right? Oh, I'm sorry, case 0. So here's my case 0, okay? If my level is low. If my level is okay, the next thing I want to do is to check the process, right? So this one is checking process okay. So if the process is okay but not done, I'm going to say process not done, okay? Then what I want to do is to go where? Stay right where I am. So there's 4. Okay, so I'm going to take him out to there. If the process is done, then where I want to go to is, I want to go to 5, right? So now what's going to happen is this guy, if the process is done, I'm going to go to 5. If it's not done, it would stay at 4. But if my level is not okay, I'm going to go back to 0 and do whatever it needs to be done. Okay, so I can do these kinds of tests inside, all right? And what gets attached here would be whatever comparison value is happening to determine level, and whatever goes here is whatever comparison I'm doing to determine whether the process is done. It could be time, it could be temperature, it could be viscosity, who knows what it is. But whatever it is, that's basically what this decision is being made. Okay, and then 5, of course, is we finish the process and then go to whatever. You might wait for it to be dumped out, turn off, whatever the process happens to be. So there's a lot of things that could happen here. But that's the basic concept of a state machine, and that's what you'll be working on here for the next homework assignment.